So let's consider this triangle. If we draw a line from the origin of the triangle through it, then we know a couple things. One thing that we know is that the distance from the origin to where the line intersects the circle is going to be the radius. So we can label this with an R. Another thing we know is that if we label this point P, and let's just call it AB, well then if we draw this angle theta, then we can say that theta is an angle whose terminal side contains the point P. And we can also determine the values of our Sig's trig functions for theta just by the information that we have here. So how do we do that? Well, we can draw a line straight down from this point P to our axis that will make a right triangle. And what we need to notice is that the distance from the origin to where this point intersected the axis is going to be A, and then the height of this triangle is going to be B. So we get the length of the two legs just by the coordinates of our point. So what do we know about R? Well, because of the Pythagorean theorem, we know that A squared plus B squared equals R squared in the triangle that we have here. So if we solve for R, we get that R is equal to the square root of A squared plus B squared. So now we can write out the values of our 6 trig functions for theta. So we have that sine, if we're looking at this triangle, is going to be opposite over hypotenuse. So B over R, where R is the radius of our circle. And then we have that cosine is going to be A over R. And tangent is going to be B over A. Now, to get cosecant, we just flip sine, so R over B. Similarly, we get R over A for secant and A over B for cotangent. So given an angle theta whose terminal side contains a specific point P, we can actually find all of the trig ratios for that angle, which is pretty neat. So let's look at some problems that uses this information. Here we are given a point P 3, 4, and we want to find the 6 trig functions for the angle theta whose terminal side contains P. So first let's plot P on this coordinate plane. We're going to go over 3 and then up 4. So P would be like right here. And then we want to draw a line from the origin to the point P. So what we know from before is that to find the sine of theta, cosine, actually any of the trig functions, all we need to know are A, B, and R. So here we have that A is going to be 3, B is going to be 4, and the only thing that we're missing is the value of this distance R. Well, we use the relationship we just solved for. We get R is equal to the square roots of 3 squared plus 4 squared to find this value, and that's going to be 9 plus 16. And then if we keep solving, we'll get the square root of 25. We get that that's just equal to 5. So I'm using all of my trig ratios over here. Okay, so it looks like using the highlighter kind of can't see them as well, so I will just circle them with red. So I want to use all of the trig ratios we just found in the last slide to fill out the information for this angle theta here. So the sine of theta is going to be B over R, so that's going to be 4 over 5. Cosine of theta is going to be A over R, so that's going to be 3 over 5. And tangent is going to be B over A, so 4 over 3. And then I can flip all of these to get these reciprocal identities. So cosecant is 5 over 4, secant is 5 over 3, and cotangent is 3 over 4. Now, note that you can solve this by drawing a triangle again. This distance would be 3, this would be 4, and then we established that this was 5, and using this angle as theta. The one problem is that right now we're in quadrant 1. So if I were to label the quadrants, this would be 1, this would be 2, this would be 3, and this would be 4. So when we're in 2, 3, and 4, we have to think about negative values. And so these triangles are actually going to be called reference triangles, and they don't work exactly the same way. So it's important to recognize that we can find the values of the trig functions just using algebra like we did here and looking at the a and b values of our point. So last example, now we have a angle theta whose terminal side contains the point -7, -24. So let's plot this point. -7 would be kind of like right here, and then we go to -24 like right here, and then we plot a point. Now we're going to draw a line from the origin to this point, and our angle theta of concern is going to be right here. Okay, and we just want to find the 6 trig functions for this angle. So once again, this is going to be given by A, and B is going to be -24. So we just need to find the value of R. So R is going to equal the square roots of -7 squared plus -24 squared. That's going to give us the square root of 49 plus 576, which will give us a square root of 625, which will give us R equals 25. So now we want to use the ratios that we found earlier. I'm circling right now to find the values of these 6 trig functions. So we'll get that sine is B over R, so B is -24, and R is 25. Cosine is A over R, so A is -7, R is 25. And tangent is B over A, so -24 over -7. And now I can flip all of these values to find the reciprocals of these functions. So secant the reciprocal of cosine, so it'll be 25 over -7. And lastly, cotangent is the reciprocal of tangent, so we'll get -7 over -24. And it should be noted that these values, in particular, tangent and cotangent, the negatives actually cancel each other out. So this is going to be a positive 24 over 7, and this will be a positive 7 over 24.